And really, this is about the fact that cloud is everywhere. If you look at the applications you use, whether it's on your phone, on your laptop, even on your game console, whether it's gaming, shopping, watching TV, sitting behind the scenes are cloud services making it all happen. But did you ever ask yourself, how did we get here? So really the aim of this talk is to help you answer that. And it's actually pretty important because as you begin your journey, in cloud as students, and as you go from students to your first professional jobs to your careers, you're going to encounter people who aren't familiar with cloud, and your job is going to be to help them understand why cloud is important and what it is. Sorry, I'm hearing some echo, so if people can maybe put themselves on mute, because I can hear some echo on the audio. Thank you. So being able to have conversations to help people who aren't familiar with cloud, it's really, really important. And I'm hoping this presentation will give you all the information and the stories and the anecdotes you need to be successful. And really, I kind of want to put you in the position that when you start your first job, after your studies, and you're going into work, you get in the lift, or you're walking up the stairs, and you happen to kind of bump into the CEO, and the CEO, who hasn't recognized you because it's your first day, says to you, "Hello, what do you do?" And you say, "I'm here to help us with our journey to cloud." And then the CEO goes, "Oh, the cloud, what is it? And how is it important to my business?" And hopefully by the end of this presentation, you'll be able to have that conversation with the CEO of your company that you're going to work for. And at the end of the conversation, he's going to go, "Smashing, fantastic, go ahead and be successful." And he's going to have confidence that you are going to help his business. So that is the aim of this talk. Now, in order to understand how we got to cloud, we've kind of put ourselves in a time machine and go back a few hundred years to kind of some of the original computers. Now, this is ENIAC, one of the first computers, and they were big. These computers were the size of small buildings. They needed lots of specialized people to run them, and they actually didn't do that much. Okay, you could think of them as kind of like giant calculators. But what happened was that over time, and through the invention of things such as microprocessors, kind of that helped reduce the size, reduce the complexity, and also reduce the cost of these computers. And IBM was one of the early kind of pioneers in this space. The IBM 650 here, this is a picture of it, was one of the first mass-produced computers in the world. And this is 1950s, even before I was born, probably before most of you were born. There were 2,000 of these around the world. And, everyone thought, going smaller was the way forward, until mainframes kind of came along, and they actually were bigger, and kind of businesses thought this is pretty cool, right? And as businesses got that taste for computers, they started to understand how computers could help them. These computer vendors started creating these bigger computing platforms called mainframes, and they were pretty amazing machines, actually, I have to say. And the reason why they're amazing, and the reason why businesses loved them, was because they were very stable, they were very durable, and it allowed actually computing to be incorporated into businesses. And this was really, really important, okay? Because for the first time, businesses now began to realize that these things called computers were not just a nice to have within business, but actually were really, really important in running of your business. Now, over time, more and more businesses adopted these mainframes, but the technology companies, started looking for ways of helping companies deploy computers, not just in these big rooms, but everywhere within the business. And this started kind of this explosion of kind of innovation as kind of companies started to look at how they could create desktop mainframes. And so you saw computers like DEC and HP, who would effectively run kind of Unix, and kind of like effectively a version of the mainframe on your desktop. And again, these were text-based, and they just ran the applications that were on the mainframe. It wasn't really until the 1980s, and again, IBM, looking to kind of create using commodity hardware and a new Intel 8088 processor as a kind of a different way to compete with those machines. They called it kind of like the small mainframes, but because it was using these off-the-shelf components, it meant they could create it very, very cheaply compared to the cost of the mainframes. And so the birth of the PC as we know it, excuse me, was created. And what happened obviously over the next 30 to 40 years was, you know, through Moore's law, through efficiencies and new innovations, the cost began to drop, the performance increased, and you know, we are where we are today, where most people now have access to a laptop or desktop computer running an operating system that helps them do stuff. So that was really important. Okay, but once we started getting, you know, computers in the hands of everyone within the business, we then started to want to connect them so that we could collaborate and we could share information and we can download. Now, this is how we used to do this. And I remember when I first started working 35 years ago in tech, this is how we would connect and get information and get the latest driver downloads. We wouldn't go, you know, get this from GitHub. We would actually go to a BBS with our modem, dial in, navigate through a text menu system, and then download the file. And probably maybe overnight, it would download the files for us. And then we'd have the latest firmware for our machines. And it was really cool at the time. We thought, wow, this is amazing, even though it was very, very slow. Now, during that time, it was still pretty hard to use these machines. Okay, they weren't very user friendly. They were quite often text based. You needed to, you know, spend a bit of time understanding how they worked. But there were some people, such as Steve Jobs, who thought, you know, we should make these things easy so that everyone can use one and everyone can have one and buy one. And so obviously he created a whole new wave of innovation that was on the basis that computers are essential. Computers help businesses, but we need to have and make more people be able to use them. And so really what happened, you know, around kind of the 90s and the 2000s was, you know, computers became the backbone of business. And, you know, it was very hard to imagine how you could run any business without a computer. And as I've mentioned before, you know, as we started trying to connect computers individually over these bulletin board networks, that was very useful. But as we started to connect them all together through networks, we realized we could do some pretty amazing things. And these networks actually that connected not just one or two, but literally hundreds or even thousands of machines in an office together were really revolutionary. And what we started to see is new kinds of software, new kinds of applications, such as email, that allowed people to start sharing information, emails with each other, which was very revolutionary at the time. But what happened very quickly is we started having all these ways of connecting computers together, but each of them were very complex, and each company was creating new applications. And so what happened was that nothing worked with each other, and so most of the time was actually spent trying to let application A communicate with application B. And actually, I spent a lot of my early years in the late 80s and early 90s, actually spending time building software that would actually help these systems speak with each other. And what actually happened was that this frustration and this complexity led to standards emerging to help simplify and make everything more interoperable. So when you hear about standards and how about the emergence of open source, this is where it kind of came from, this complexity and this pain point of doing everything. And a good example of this was the internet as a standard way that emerged for people to share information and connect computers to share resources information. And so really kind of like in the middle of the 90s, this is where kind of the web as we know it today was actually born. And the picture there is actually the first web browser I used, Mosaic, which when we started using it was actually revolutionary. But now if you were to look at it today, you would think, my God, this is rubbish, but at the time it was very, very, very revolutionary. And so I mentioned already, these standards emerging to help everything glue together. And open source, which was formed in 1997, was actually central to that story. And really what open source enabled people to do was create these standard pieces of software that you could run anywhere in a way that would work with other systems, okay? And it's really hard to, kind of get this across, but we wouldn't really have the web as it is today if it wasn't for open source. And actually we wouldn't even have things like the cloud either. Now, we've already talked about businesses and how computers and businesses were kind of like a very good match, and how businesses loved computers. But what happened in the 90s and the 2000s is business started investing more and more money in computers. And so much so, and as they was writing applications for their businesses, a new kind of computer emerged called a server. And this was a specialized machine, and it was specialized because it had lots of memory, lots of CPU, and lots of storage. And it was useful because it allowed businesses to share information within departments or within the actual organization itself. Before we had servers, we would just use normal machines, normal desktop machines. But it wasn't until the emergence of these new machines called servers that had like lots of space for storage, had lots of memory, had more CPUs, that these machines could actually help businesses use that extra capacity to create their applications. And businesses, once they had these servers, they started writing more applications and deploying them on these servers. Now, as businesses started using more and more computers, suddenly we actually start to see a pattern. And the pattern was that they would buy these servers and they would write these applications and they would deploy these applications on these servers, but they would be very, very inefficient. And you'd have a very expensive server. And bear in mind that back in the kind of late 90s and early 2000s, a server might cost you $10,000, $15,000, $20,000. The business would buy these, and they would get installed, and then they'd put their applications on, but they'd only then be used about sort of like 10%. And so they were like really only using a fraction of the capacity. And it's like you going out and buying a Ferrari sports car, but you only use it to go and to the shops and back, right? It's a huge waste, right? A Ferrari wants to go on the racetrack. It wants to be driven fast. It doesn't want to go to the shops and back, right? And the same thing with these servers. They were basically built to serve and be run much higher, but businesses would only use them very, very low. And there's lots of different reasons around that. And so what happened was virtualization came to the rescue. And virtualization was, again, this is kind of through open source. Virtualization technologies such as Zen and KVM came along and allowed businesses to take those physical servers and virtualize them. And so what we mean by that is we would actually take the operating system from a physical machine and convert it into a software construct, a logical one, and allow us to put lots of those in a physical machine. And that then allowed us to increase the utilization of the physical server, even though those logical virtual servers might still only have been running at 5 to 10% utilization. And around 2006, VMware released their kind of very popular ESX virtualization hypervisor, which kind of dominated business, and from that point onwards, really most enterprise businesses started virtualizing and running virtual machines rather than physical, rather deploying their applications on virtual machines rather than on physical machines. Now, I talked about the web and how organizations started, kind of connecting computers through networks. Well, this network started going beyond just one company, and organizations, first of all, universities, then businesses, started creating kind of like this these networks across the world. And the kind of the web that kind of sat on top of that started to get embraced, not just by people and academics, but by businesses and customers. And very quickly, you had tens of thousands, if not millions of people who were creating their own websites, who began using their own emails and were accessing web pages to do more and more information. And we started to see the first businesses start on the internet, and Amazon was one of those businesses in 96. I think this is the website from 97. Again, looks very different to what it does today. Now, IT, because IT business was now depending upon IT began to grow within companies, and what they were looking to do was to try and figure out how to be efficient in using that growing IT function. So they started to look at automation as a way of improving the efficiency of IT. But what also happened was that we started seeing IT now being something that was just a department that used to live in the basement. So when I first started working in IT, as IT people, we were treated very, very poorly. We were given the worst desks in the worst locations, and it was next to the mailroom typically. And what businesses realized is that this thing called IT was really important, and the businesses that were doing really well, they figured out how to use IT well. And so very quickly, the boards began to realize they needed someone on the board who looked after IT, and that person was the Chief Information Officer, the CIO. And it was their really job to kind of like help move IT from being just a cost center, which is basically something that you just spend money on and really just like buying calculators or buying desks, to actually a profit center, effectively as a way of helping the business make more money and a competitive advantage. And this is really, really fundamental. This shift that happened in the late 90s, this realization that businesses needed to get more of a kind of a handle on this. And so the CIO started to structure IT within the business, and we started seeing a growth of new roles within the business. Smaller businesses tended to have maybe one person do 2 or 3 of these things. Even smaller businesses, one person might have been doing all of them. But the fact is that these roles, these different disciplines started emerging. So I can hear some noise. So if you can put yourself on mute if you're joining, that'd be great. Thank you. Right. And so businesses then started having these things called data centers, and these data centers were full of those servers that they had, all running virtualization, all running virtualized workloads, all running at low utilization. And whilst all this was going on, whilst business was growing and getting more complex, and building off the stuff from the internet, we had a company called Salesforce, led by Mark Benioff, who in 1999 coined the term software as a service. And effectively what he started doing was started creating software and delivering that software over the internet as a service. And this was a kind of a new architecture model that allowed effectively customers to think about how they built software differently. And we call this, a kind of a loosely coupled architecture. Whereas before, applications were very kind of like monolithic and all very tightly grouped together. Around 2000s, the application architecture started to rethink and reimagine how they might look in a services model. And it was actually called service orientated architectures at the time, SOA. And that kind of led to then what we see kind of very common today, kind of the API economy, whereby this decoupling led to kind of this further innovation around how applications would expose their functionality as an API, and not just necessarily as a user interface. And this was like kind of in the very, very early 2000s. This is a very important kind of piece because this is all coming together. Now go back to business now. So we got IT and business. They're getting bigger and bigger. It's getting more and more complex. And like all good businesses, when things get expensive, when things get big, they look for efficiencies, and so they started to outsource it. But when they outsourced it, IT got slow. When you think about it, what would typically take a business maybe 2 or 3 days could end up taking 2 or 3 months to do, because you had all these different approvals that were needed, different companies, and it wasn't really straightforward anymore. And so we got to a situation where IT wasn't really working for business, even though the business were dependent on this IT. So bringing this all together, okay, all these forces came together with the cheap hardware, the kind of reduction in the cost, but the increase in performance of the PCs. We had open source technologies as well as proprietary technologies lead to virtualization technologies. We had open source software emerge, such as Linux. We had the networking growth explosion that was driving the internet. And then we had the emergence of these new architectural software patterns, okay? And so kind of what happened, okay, is these forces came together to fix problems that had started around why IT wasn't working for the business anymore. Because businesses like Amazon at the time were asking themselves, how can we make it so that we can actually create value for our customers more quickly? How can we actually experiment and innovate more? Because this was one of the things that as a company we lived and died for, like many other businesses, right? They were really struggling with how slow everything was. And so this kind of led to the creation of the cloud in 2006. And it was those combinations of forces, so all of these, that actually was kind of critical and necessary for the creation of AWS, because we ran on dedicated specialized hardware which we built, that was built on this cheaper faster hardware. We used open source virtualization technologies. We were deploying off the back of the global backbone network, and we implemented an API services based architecture. And so that was kind of like the perfect opportunity, really, for the kind of AWS to become born. And AWS stands for Amazon Web Services. And at the time, it was a set of APIs that allowed you to provision infrastructure in the same way that you would typically do it on-prem. Now, at the time, when I first started using AWS in 2008. Before then, I was architecting and building solutions based on VMware. And it would typically take me 2 or 3 months to actually get a VMware infrastructure up and running, from hardware being delivered, racked and stacked, networked, software installed, all that. It would take that long to actually get everything up and running. The first time I used AWS, I created an account. I used my credit card to create my account. Within 15 minutes, I had 2 virtual machines running CentOS, running in the cloud, doing stuff for me. I just couldn't believe it. And I thought, wow, this is the future. And at that moment, I realized that I was going to dedicate my life to working in the cloud and not on VMware. And so, yeah, so that's the cloud. But what is cloud, right? So I've talked a lot about all this sort of the backstory, all that history that led to the point of the cloud being created. But actually, what is the definition of cloud? And this is really important. So if there's one thing that you take away from the session, is being able to tell someone, if they ask you what cloud is, that the cloud computing is the on-demand delivery of IT resources over the internet with a pay-as-you-go pricing model. Okay, so memorize that, okay, because that is your definition of what cloud computing is. Now, cloud has had a massive impact on the IT industry. But to go back to the business, okay, because it's all about really, IT is cool, but IT without business is just pointless, right? And businesses only want to have IT to help it solve the problems that they have and help them serve their customers. So what are the problems did it help solve? So let's take a look at some of the problems it helps solve. So let me just okay, whoops, I'm not sure what's happened there. I seem to have lost my presentation. Can you still see my screen?
Yes.
Yes, you can see your screen.
Yes, you can see your
You
screen.
can. Okay, cool. Right. So so effectively, before I do that, what happened was that when cloud was launched, what happened was we saw a particular segment and customers really adopt cloud because of the way that it was, this pay-as-you-go model. And what we saw is that lots and lots of cool ideas began to flow, and innovation exploded off the back of the cloud. And people who typically had ideas, but didn't have the capital to provision infrastructure, could suddenly now use AWS to build stuff that we'd never seen before. And what then happened was cloud actually then started changing how we started building things. And one example is at Amazon. So on the left-hand side, the original architecture of Amazon, OBDOS, was this monolithic architecture. And the right-hand side is what just one AWS service, EC2, looks like now. It's basically a collection of services. This is an old picture though, so it has changed since this, but you get the idea, right? Is that it changed how we built stuff, and we started moving to this more API and service-driven environment. And effectively, cloud enabled us to do stuff that was just literally just not possible before. And this was something that we didn't know at the time, okay, and was only possible because once we launched AWS, businesses were able to do that experimentation and try this really, really cool stuff, and do all this really, nice cool stuff. So going back to why this is important to businesses and why businesses today are moving to the cloud, I'm going to share 5 reasons, okay, with you that again are really important to have in the back of your mind when you're having conversations with people about cloud. No, cloud is not something that is just technology. If you talk about cloud in just technology sense, then you're really missing the bulk of why cloud is important. Cloud technology is really, really cool, but then so is lots of other technology, right? What really sets cloud apart is actually how it helps the business. I'm going to share 5 ways in which cloud is absolutely critical to business today. And the first one is cloud helps businesses become more agile. And there's a great quote, one of my favorites, okay, from Klaus Schwab, who basically was the CEO or the chairman of the World Economic Forum. He wrote an essay, I think, called The Fourth Industrial Revolution. And in it, he says that, in today's world, it's not the big fish that eats the small fish, but it's this fast fish that will eat the slow fish. And what basically he was saying is it doesn't matter how big a company you are, if you are not agile, if you can't move quick enough, then you will be beaten by these speedy entrants into the market. And you only have to look to lots of examples out there where big companies thought they could survive just on their size, but new organizations that came along that leveraged the cloud were speedy, were more responsive, more agile, came and then very quickly dominated their market. So the one I typically use is Blockbuster, which is a video library service, and Netflix, which is that on-demand streaming of content. And Netflix laughed when Netflix wanted them to buy them, and now look what happens. There's no longer Blockbuster, even though they were huge. They were a huge company worldwide. Now they just don't exist. Okay, and Netflix are the big fish now. So agility is the first business reason why cloud is important, because Netflix couldn't have existed without cloud. Okay, it didn't have the capital, didn't have the resources to buy all that infrastructure up front. It relied on the fact it bought just what it needed, paid what it used, and grew. And as more money came in, it was able to fund that growth. The second one is innovation. Now, I'm hoping that some of you on this call, are going to be the future millionaires or billionaires. You've got some great ideas. And when we all have our ideas, this in our head is what we think our great idea is going to do, right? We're going to have our idea and it's going to be super successful. It's going to go, stratospheric, and it's going to make us very, very rich. But what happens is that we get to a certain part and you know what? No one is interested. We can't convince people. And actually the reality of the situation is the innovation dance is up and down. Basically, you have an idea, you experiment, you try, it fails, you learn, you try again. And at some point, you realize that actually all that learning you've had, you've now hit on the right product. And then you start taking off and being, your successful business. And so this is an experimentation process. And innovators like to experiment, and experiments allow us to do that kind of confirmation or rejection of those ideas. And really you need a way that allows you as a business to see what your kind of minimal viable products are in a way that's not going to cost you a lot of money. Now, when before I joined AWS, I worked for one of the big four. And if I was to do an experiment, a big experiment, I ran many of these, it would cost tens of thousands, if not more, just to run an experiment. And of course, if you're spending a lot of money running experiments, it means you're going to run fewer. So moving to cloud allows you to actually lower the cost of running those experiments, therefore allows you to reduce the cost of experimentation, therefore you can innovate more. So we've got agility, we've got innovation. The third one is elasticity. Okay, we talked about this 5% utilization within the data center. And the reality is that when you buy computer equipment, you buy it and you buy the capacity, right? So the red line. But actually what you use in your day-to-day life in the business isn't aligned to the red line. Okay, because at night you're sleeping hopefully, and no one's using the servers. In the morning when everyone comes in, it's really, really busy. Maybe at lunchtime it goes down because everyone hopefully is having a leisurely lunch. And maybe in your business peak periods it goes up. But there's this gap, okay, between the blue line and the red line, and that gap, okay, is waste, right? And as a business, you've paid for that. You've paid for that waste. And so what you really want is you want a way of not paying for that waste. And so what cloud allows you to do, it allows you to create this green line, okay? And it allows you to map what you use to what you need, okay? From an infrastructure perspective, whether it's like on and off, whether it's gradual growth, variable peaks, bursty, or even predictable lows, okay? It allows you to better map what you're using, and therefore now you have less waste, okay? And if you have less waste, this means that you can actually reduce your costs as well. So we've got agility, we've got innovation, we've got elasticity. The next one is global, okay? Because setting up any business in your own country is hard, but setting up anywhere else in the world is even harder. And I've had to do this a few times in my previous job, and it would take many years to set up everything we needed in another geography to deliver an application for a business or for our customers. And so being able to have the same infrastructure that you're used to everywhere around the world, or at least in the places you need it, is super important. And in one click, I can deploy locally, or I can deploy in another part of the world. And I've not had to do anything different. And this is a really, really important aspect of cloud, because it allows you to have that flexibility of where you deploy your workloads, so that they're closer to your customers. And in today's world, we're actually in a situation where deploying to cloud is actually a continuum. So we have the cloud on the left-hand side, and we have, in this instance, AWS regions, but we also have the ability to run workloads in your own office. So even in those data centers that businesses have, we can put racks in there, or we can install software on there that connects to the cloud, which means that effectively your workload is using the same APIs, the data is accessible everywhere, and you can have this continuum of using your compute or your storage based on the principles of cloud. And we are in a situation today where literally cloud is everywhere. And this is a nice diagram that I like to use. We're even in space. Okay, we've got base stations that allow you to kind of use satellites on demand. We've got services that allow you to deploy on rugged edges in very kind of disconnected environments. We've got the on-premise stuff I've just talked about, as well as the AWS cloud. So wherever you have your workloads, there is a place for you to deploy them on. Now, AWS invests a lot of money in these regions, in these data centers. And what this means is it allows you to benefit from the innovations we have around sustainability, which means that typically customers, they use less power when they're using AWS services, and they also use less services. And we've actually produced reports that show that customers that use AWS tend to use, 3.5 times, they're 3.5 times more energy efficient, and they actually lower their carbon footprint by 88%. So a lot of businesses really, really are benefiting from this global scale. And the fact that wherever you go and wherever you deploy your resources, they're more efficient than typically you are able to do for yourself. So we've had agility, innovation, elasticity, and global. And the last one I want to talk about is security. Okay, security and resilience. Now, it used to be the fact that as a business, you had to make a choice. You either, you had to decide you wanted to be secure, but then you slowed the business down, or if you went quick because the business wanted to go quick, you would then potentially put yourself at risk. And traditionally, this was because so managing risk and security in businesses was really hard, because within data centers there was this poor lack of visibility. It was really hard to know what was actually going in to your data centers, and that was partly because there was still not enough standardization within that data center, but also because there was a low degree of automation. And so therefore businesses had to make this choice around moving fast or staying secure. But cloud actually now allows you to change that. You can actually move fast and you can stay secure. And the reason is that when you are using cloud, you're effectively connecting to APIs. And because you're connecting to APIs, you have visibility of everything that you do. Now, that means that not only can we now see and have visibility in what's going on, but we can also have greater automation. And if we have greater automation, it means that we can rely less on humans, but use the humans to create code that then automates the provisioning of that infrastructure. So you'll hear things such as infrastructure as code, and this is what they're referring to, the ability to automate the provisioning of their infrastructure. Now, the other thing that cloud providers do is they do all the certifications around regulatory compliance. Now, in my previous job, we typically had a team of around 20 people that would do this, and they would do it for every regulation for a particular country, and it was a really tough job. Okay, so it cost businesses money to do this. Now, when you use AWS, you have all these certifications done for you, which means that it's easier now to start running workloads and tell your customers that you are running in the you are now certified against all these compliance regimes. Now, within cloud, within AWS, we have this concept of and it's very important that people understand this, is that AWS commits to securing the cloud. So we talk about the security of the cloud. So this is the data centers, the physical security, the actual security of the servers. All that stuff is managed by AWS. However, you can still we still have the world-class security, but as a customer, if you're not doing your job and making sure your applications are secure, you can still be compromised. So we talk about security in the cloud is still the customer's responsibility. So this shared responsibility model allows customers to understand what they need to do to be secure, and they also understand what AWS will do on their behalf. And that's really, really important. Now, back in 2008, we launched 2 services of AWS. We're now in 2023. We now have over 200 services, and those services cut across compute, storage, application, middleware, container, hybrid, robotics, IoT, analytics, database, and this is just some of them. Okay, so there are now more services that you can use to build your applications. Now, on top of that, for the last 12 years, AWS has maintained its leader in the Magic Quadrant as the cloud leader. And, as a result of our leadership in this space, we have millions of customers that trust us day in, day out to run their mission critical workloads. So really, cloud is the new normal. Okay. But what I'm interested to find out is, what will you build here on this call? What will you build in the cloud? And so that's the end of the presentation. Before I open up to questions, I do want to talk a little bit about cloud clubs. You're here because of the Cloud Club. They were launched in 2023. We have 2 cloud captains here, which is great. You can scan this QR code to find your lovely cloud captains. If you haven't done also already, we're looking for people to join the AWS Cloud Club's meetup group on meetup.com. So if you haven't done so already, then please use that QR code or that link to actually to join that group, and that'll keep you up to date with all the meetups such as this one that are happening. And so with that, I'm going to basically hand it over to questions. I think we've got 10 minutes left for questions. So have we got any questions? Yeah, we've got some questions already in the chat. So let's have a look. So yes, I will. I'm happy to share the slides after the session. I'll share them with the cloud captains. Actually, you already answered that. So the meeting has been recorded. Slides will be provided. Yep, absolutely. So does anyone have any questions? And you can feel free to go off mute now. I'm happy to speak to you, or you can use your voice if you want. So we've got a question from Michael. How often does this take place and what extent is the training? I'm assuming you'll talk about the Cloud Club meetings. I'm going to defer that to your Cloud Club's captains, who will tell you about that. They'll organize all the sessions for you. So if you have any things specific you want them to cover, then engage with your Cloud Captain.
Oh, hi, Michael. Good evening. Please kindly join the WhatsApp community, and all your questions will be answered there. Thank you.
So Hassan, what is the need for cloud computing professionals? What exactly do they do? Okay, so cloud computing professionals, they work with cloud on a day-to-day basis, and there could be different activities they do. We have some cloud professionals that do development. We have some that do operations. We have some that do support, some that do security. So there are a number of different activities that that you do. In the same way that organizations used to do this within their own business, they're now doing this in the cloud as well. So I hope that answers your question. I need you to explain why AWS. We have other cloud computing services. What do you offer that others don't? So AWS, we focus on our customers. So I think what you'll find with AWS is that we have the broadest and largest number of AWS services. We have the largest number of AWS regions, of cloud regions. And so a combination of both of those, plus the fact that we work on behalf of our customers, 90% of our roadmap is driven directly by customers. And I think this is what really differentiates AWS from other people, okay, is that we are committed and obsessing over our customer needs, and we work relentlessly to make sure that our services are what they expect. I have been very, very impressed in my time here to see that commitment. It's not just words. And I think where I see it most is in support. Our support is absolutely fantastic. You know, and when you become an AWS customer, you get dedicated support resources if you sign up for the support plans, and they're just incredible. They really are amazing. So I think there are a few things that differentiate AWS, but mainly it's the fact that we work back from our customers. They help drive our roadmap, and the fact that, you know, we have been in this game longer than most people. And we like to say there's no compression algorithm for experience. And so, you know, we are very good at running cloud services on behalf of our customer. I think that's really what sets us apart from everyone else. Okay, Daniel, AWS S3 and EC2 are very common, especially with the memes. Can you quickly explain what they are? Yeah, so S3 is object store, and EC2 is compute, virtualized compute. So I talked in my presentation about hypervisors and virtualization. Well, EC2 is AWS's virtualization service. So in VMware, or if you're using something else, when you create a virtual machine, EC2 is the same thing. But what makes AWS unique in that respect is we use something called Nitro. Nitro is only found in AWS, and it is an incredible piece of technology that allows us to provide you know, different kinds of compute virtualization environments based on different needs. So we have over 700 different combinations based on whatever workload you have. S3 storage, object storage, is effectively storage, but not like a hard disk, but it's storage that's accessible via an API. So you have some files, you want to save them, you use a piece of software to effectively take the files from your local machine up onto S3 through the API. So that's S3 and EC2. The work of cloud engineers, I think I've kind of covered that. Basically, they vary, but basically, cloud engineers, they work day in, day out within the AWS APIs, building solutions for their customers or supporting solutions for their customers that are already deployed. Salman, what's the difference between infrastructure engineer and DevOps engineer? Well, that's an interesting question. So infrastructure engineers typically build infrastructure and then hand it over to or make it ready so that you can deploy applications. DevOps engineers tend to take that stuff and put the application pieces together as well. And so DevOps, kind of, you can think of them as like working together with infrastructure and applications to automate the provisioning and deployment of the applications in an automated way. Again, using that automation that clouds provide. And DevOps is something actually that I talked about. New ways of working. DevOps emerged because of cloud. We didn't have DevOps before cloud. And it was because the fact that cloud services are API driven and we have automation that companies started creating new ways of working that went on to become what people now refer to as DevOps. Yes, Akenda. Well, I hope your support experience is going to be great. Great questions. Keep the questions coming. We've got 2 more minutes before I have to go. And yes, please make sure you fill out the attendee form. That's very, very important. We know we are driven by feedback. I'm going to ask one small thing before we go. Right? It's something we ask all sessions in Cloud Clubs, and I'm hoping that some of you are going to do this. I would love to see you on your webcam. Open your webcam, and I would like to see you make the letter C with your fingers, and I'm going to take a picture of everyone doing the picture C. So if everyone could go on their camera, we'll give everyone a few minutes to do that. If you can come up on your camera, and if we can stop the presentation so we can get everything on full screen. So I think who's sharing? I think Joshua, if you can just basically stop your screen sharing so we can get everyone on the webcams. So for those people, if you can get your webcams on, okay. And if you can make a C shape with your fingers like that, okay. Oh, okay, right. So we need some more people. Like I run a competition. Okay, I want us to win. So far, the record is 9. Okay, so we need more than 9 people. Okay, to do the C shape with their effect. So come on, let's get everyone on their camera, even if it's only for 2 seconds. I want you on camera just so that I can see your C shape for Cloud Clubs, and then we'll take a picture, and then that's it. That's good. Come on, more. We want more. We want more than 9. Come on, we can do it. We can absolutely do this, right? We can absolutely do this, right? That's it. This is fantastic, right? So let me just make sure we got some pictures going on here. Okay, come on. Let's see if we can get a few more. Can we beat the record? We got 1, 2, 3, 4, 5, 6, 7 so far. We can do better. Come on, people who are not on their cameras, quickly get your cameras on. Let's see if we can get 10. Let's see if we can beat the record and get 10. Come on, we can do it. We can do it. It's dark there. Okay, fair enough. I didn't realize if it's too dark. Come on, I'm gonna count down from 10. Let's see if we can get to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and this is the one. That's it. Picture taken. Thank you very much, everyone, for your time. I've got to go now, I'm afraid, but it's been a pleasure. I wish your Cloud Club all the success, and please keep attending them. You're going to learn loads of things here, and cloud is the future. So if you want to be involved in tech, you need to know about cloud. So I look forward to seeing you in the future.
Thank you so much, everyone, for attending this event. It was great. Please kindly fill the attendee form because it's very important and it makes your presence counts. Thank you so much. If anyone has any question, you can ask me about the club or anything.
Hello. Is that audible?
Yeah.
All right. Good.
Hello.
Thanks so much,
Joshua, are you
guys,
here?
for coming.
I can see someone asking the question, what's next after this? Please kindly
Yes.
fill the attendees form and please join the WhatsApp group. We'll broadcast the next thing, the next step after this.
All right, guys. I'm having issues with my network. Actually, today is really not my lucky day. All right, so the boot camp comes after this,
Yeah.
and that's the next thing we are looking to do. So if you want to participate, if you join the community, we'll also outreach the boot camp. It's going to take place for a couple of weeks where you get to play. The
Yeah.
course is more like a game, so it's
I'm
very
having
interactive.
issues with my
Something you
network. I'm
really enjoy.
really today is really not my lucky day. All right. So the boot camp comes after this, and that's the next thing we are going to.
All right. Thank you guys for coming. Thank you guys for coming. Please join the community. Fill the attendance form is important, and we'll also send your certificates over to you. For those of us that registered before joining the link today, I'm going to send the certificates over to you. So please, it's very important. All right, guys. I'm going to end the meeting now. Thank you for coming, and this has been a pleasurable time. See you guys now. Okay, the form.
Yeah, they should fill the form with their email and everything. So the certificate will be sent to them.
All right. All right. Thank you, guys. The link, everything is in the chat. Yeah. Thank you, Daniel. The Cloud Club, University of Ilorin. I think this is it on the
Name of the event.
Sorry, did I hear someone speak? Hello? Okay, the link. Sorry, please, if you are there, just send the link again, please.
What's the name of the event? What are we to fill in the space meant for the name of the event?
Oh yeah, Daniel just dropped that now. How did we get here? I reply that shows it. Oh, sorry. Check the chat. You should see there. It's how did we get here? Any other question, please? A beginner's guide to the cloud. How did we get here? Beginner's guide to the cloud. All right. I think that's all. Once again, it's been a very pleasurable time. Hope you guys have a wonderful evening. Bye.
What do you think is going to happen? What do you think is going to happen? Meet your man. Meet your man. What do you think is going to happen?
The name of the club is AWS Cloud Club at the University of Ilorin. It's on the chart. And the name of the event is How Did We Get Here? A Beginner's Guide to Cloud. Once you are done filling the form, you can join the group if you haven't joined yet, and you can probably leave the meeting. Thank you so much for attending, for coming. We really appreciate your presence. If you are still on the call, have you filled the attendees form? Kindly fill it and you can leave the call. Thank you so much. I just thank you. Joshua, are you here? Mute the call. Okay. Wait, you go do. Allah, fuck you.
Hey, what's up? Hello. Hey, what's up?
My boss, I'm with you. I'm with you.
So I'm trying to stop the recording. Okay, I did.
Did it,
Okay.
have you